Hi everyone. Today we're doing what we call the protic nature of acids. Our syllabus outcome is write ionic equations to represent the amphiprotic nature of some salts, for example sodium hydrogen carbonate and potassium dihydrogen phosphate. So make sure you've done the revision questions. Here are the answers. To calculate concentrations of H plus or OH minus at equilibrium, we always need to use an ice table. Initial change equilibrium. Always use the ice table assumption. Remember that if x is much less than y, y minus x is approximately equal to y. You also need to use pH, POH equations for these questions, such as those ones listed there. Okay. Now, protic nature of acids. So any compound that can donate or accept a proton is known as a protic compound. For example, acids are protic compounds as they can donate protons. Acids that can donate one proton are called monoprotic acids, and acids that can donate more than one proton are called polyprotic acids, in particular diprotic, triprotic, tetraprotic, etc. So polyprotic acids. Diprotic acids are acids that can donate two protons. The most common ones of these are sulfuric acid, sulfurous, chromic, and oxalic acids. Okay, so basically when they dissociate, they release two H pluses instead of one. Triprotic acids, the two that we only really deal with are phosphoric acid, which is H3PO4, and citric acid, so C6H8O7. And as you can see, when you stick them into solution, they can donate three. So triprotic acids can donate three protons. There are very few polyprotic, so more than that. So tetraprotic, while they do exist, they're not very common. The one that we do come across the most is EDTA, which is ethylene diamine tetraacetic acid. So EDTA, you might have heard of it before. It's actually a really good complexation agent. It wraps around heavy metals quite easily and helps get them out of bloodstreams. But as an acid, it can donate four protons and form the tetraacetate. Okay. Now, amphiprotic substances. Amphiprotic substances are compounds that can act as either an acid or as a base. In other words, they can either donate a proton or accept a proton. Water is an excellent example of amphiprotism. So water can act as a base and accept protons from acids. So something like HCl, HCl can act as an acid, donating a proton to water, which acts as a base. And so that water can accept that proton and form that H3O+. It can also act as an acid by donating a proton to a base. So here we have ammonia plus water. This is ammonium plus hydroxide. So we can see that water can go either way. And here's some other examples that are amphiprotic substances. So they're not super common, but there are plenty out there. So again, firstly, water can become H3O+ or OH-. Hydrogen carbonate, so HCO3- can become H2CO3, so carbonic acid, or it can become carbonate. Next one down, we have dihydrogen phosphate. It can become phosphoric acid by gaining a proton, or it can lose one to become hydrogen phosphate. Hydrogen phosphate itself is also amphiprotic, so it can go back to being dihydrogen phosphate, or it can just become phosphate by itself. And then lastly, hydrogen sulfate can gain a hydrogen to become sulfuric acid, or it can lose one to become sulfate. Some examples. So the two big examples that we were given were the hydrogen carbonate, and then there's the phosphoric, I think it's dihydrogen phosphate. So firstly, write chemical equations showing how bicarbonate ion can act as either an acid or a base. So we can have the hydrogen carbonate reacting with water. The water can act as an acid, donating a proton to the hydrogen carbonate, forming carbonic acid. Or we can get it going the other way. The hydrogen carbonate can donate a proton to water, forming carbonate and H3O+. Another example, so we want to write a chemical equation showing how the dihydrogen phosphate ion, so H2PO4-, can act as an acid or a base. So again, we can react it with water to form H3PO4 and OH-, or it can also form HPO4-2- and H3O+. So you can see both of them, one's acting as an acid, one's acting as a base. So summary for today. Acids that can donate one proton are called monoprotic acids. Acids that can donate more than one proton are called polyprotic acids. And amphiprotic substances are compounds that can act as either an acid or a base. And now I know that was a very short lesson, but that's all for today, so thank you very much.